Hello, welcome to the Henstitute. This is some more AP Physics 1. We're continuing with Chapter 1. This one I talk about the concept of trigonometry. Really what we're going to look at is right triangle math. So we're going to go through what most people would probably say just your basic geometry, but to kind of relate that to what we need here. So to start off with, I'm going to try to use as many of the normal terminology that you're familiar with. For example, the three sides of my triangle here, I've got a 90-degree angle here, so this is a right triangle, is basically going to be A, B, and then this side is C. C is always going to be my hypotenuse. It is the side that is opposite my 90-degree angle. I'm also probably assuming that you are familiar with this symbol right here, which is the Greek letter theta. And it's just a fancy way of representing an angle. So we use x in early algebra to represent any unknown. Here in geometry or trigonometry, theta is the most common way to represent an unknown angle. Just Greek letters tend to get used for angles. Not really sure why, just kind of a common notation. Now I know I have another angle up here, but I don't know what it is. I don't really care. I could pick another Greek letter to represent it, or I could also call it theta or some other version of it, but for right now I'm not going to worry about that. So why do I need this type of stuff? We're going to try to extend this and also use these to try to solve some problems. So I've got these different parts. One of the other things that it brings together is my different trigonometric functions. Or just trig functions in general. And these trigonometric functions are sine, cosine, and tangent. I haven't written out the full words because this is the common notation just to simplify it. And I've written it out the way that they would set up based off of this triangle that I have over here. But I assume a lot of you have probably learned this silly little word, SOHCAHTOA. And you're going to hear me use it a lot. It's just a way of representing sine, cosine, tangent. So for sine, for example, the sine of an angle is equal to the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse, and so forth. So when I wrote this, I have the sine of an angle. So this is the sine of theta is equal to the opposite side, which is B in this particular case, over C, which is the hypotenuse. So it allows us to kind of figure this out. So let's try to apply this in some fashion. So let's say you had some building and the sun was up in the sky and it shines down across the top of this building. It creates a shadow that is 67.2 meters long from the end of the building. And if you were to sight from the end of the shadow straight up to the top of the building to the sun, you would be sighting up at a 50-degree angle is basically what the idea here is. Could you find the height of this building? And I would say yes, you can. So it's kind of a neat concept. So if I have an angle and I know I want to figure out the opposite side and I have the adjacent side, whenever I think of opposite and adjacent, tangent is usually the first thing that pops in my head. So I'm going to grab the fact that the tangent of the angle is equal to the opposite side, B, divided by the adjacent side, A. Then I just substitute in the information I have. I know that it's a 50-degree angle, and B is what I'm trying to find. I'm trying to figure out what the height of this building is, and my adjacent side is my 67.2 meters. Once I have this set up, it's really just an algebra problem. So I would try to solve for B. So I would multiply by that 67.2 meters on both sides. That would cancel it out over here. That would take this quantity and multiply it by the 67.2 meters. And then I just have to multiply that out to figure out what B is. Now the problem I run into on my setup here is I don't actually have a scientific calculator. So I'm going to pull out my scientific calculator on me. Make sure your scientific calculator is in degree mode. If you do not know anything about that, contact me and I'll try to help lead you through how to do that. But you want to make sure that it is. So I would type in 67.2 multiplied by the tangent of 50 degrees. Hit enter and I get 80.0. Actually, I'm going to write all of the numbers here. 0.858. 4142. Now I definitely don't know the height of the building all the way out to that particular precision. So I go back to my original numbers. I've got 67.2, which has 3 significant figures. I have 50 degrees here. However, the picture actually says it as 50.0 degrees. Typically, I don't use degrees to determine significance because you're taking a function of it. I usually use any other measurements. So I would probably keep the 3 here and say 80.0, but this 8 will round it up to a 1. So I would probably round this to 80.1 meters. Or if you did see this and say this only has 1 significant figure, 80 would probably be acceptable. I don't think this 0.1 meters is going to change your precision that much. And there you have it. There's a simple little problem dealing with using trigonometry or right triangle math. Can it keep going? We also know that we can find angles by using the inverse functions here. So taking the inverse sine of your opposite over hypotenuse will find that angle, or the inverse cosine, and so forth. And so if I was faced with a situation like this, let's say that I have a boat that's sitting out there. It's 14 meters away from the shore, and the water has a depth of 2.25 meters. Assuming the slope of the land under the water is continuous, what is the angle of this declination? In other words, what is this angle right here? And if I was trying to find that angle, I have the adjacent side to it. So in other words, let's kind of treat this like I have a triangle here. I'm thinking of the depth as coming straight down, so this would be where my right angle is. So if I'm trying to find this angle, I have the adjacent side and I have the opposite side. So again, I would be using tangent, but we're going to jump straight in. If I want to find the angle, I actually have to take the inverse tangent of my opposite side over my adjacent side. So I would be taking the inverse tangent of my opposite side, which is 2.25 meters, over my adjacent side of 14 meters. And this is what I would plug into my calculator to try to find that actual angle. And again, make sure that you're in degree mode. So you actually hit the second key and then hit your tangent. And that should write a tangent to the -1 and then 2.25 divided by 14. Hit enter, and I find out that this angle is 9.13 degrees if I keep 3 significant figures based off of those, and that gives me a nice little angle here. Then you could do other things with this, as if this declination continues until you are 22 meters away from shore. What is the depth of the water at this distance from shore? So you could use this angle now to try to figure this out. You could also use similar triangles that would figure it out. Really, you're using some trig functions there. I'm not going to go through that one, but I think that one's kind of a neat extra little addition. The last thing I just want to kind of remind you about is the idea of the Pythagorean theorem. If we ever need to find sides and we don't really know anything about angles, or once we have found the sides and we want to find other sides, we know that the hypotenuse squared is always equal to the sum of the other 2 sides squared. So a squared plus b squared always equals c squared, and that allows us to try to figure stuff out. Hope you've enjoyed this edition of the Henstitute, talking a little bit about trigonometry, specifically just some right triangle math. Thanks.